Dear student, Assalamu alaikum. Welcome to the course of Data Structures and Algorithm. I am Dr. Zishan Iqbal, Assistant Professor in Institute of Computing. Today is my lecture number 16, in which I'll be explaining you about new data structure which is called stack. Objectives of today's lectures include to understand the abstract data type structure which is known as stack, and to be able to understand the implementation mechanism of stack using a pointer variable, and in the end to understand the performance evaluation of basic data structure stack. Now let's begin with defining what is stack. A stack is a container of objects that are inserted and removed according to the last in and first out principle. In the push down stack, only two operations are allowed. One is known as push and other is known as pop. Push the elements or item into a stack, and pop the element or items out of the stack. A stack is a limited access data structure. Elements can be only added or removed from the stack only at the top position. Push defines adding an item onto the top of stack, while the pop removes the item from the top. A simple example will be to think of a stack of books. You can remove only the books on the top. Also, you can add the books only at the top. Stack is also known as ordered list, in which insertion and deletion can be performed only at one end, that is called top. A stack is a recursive data structure having pointer to its top elements. Stacks are also known as last in, first out elements, that is, the element which is inserted first in the stack will be deleted last from the stack. Of stacks are not limited. The simplest application of stack is to reverse a word. You can push a word into a stack letter by letter and then pop letters from the stack. Another application will be the undo operation used in many editing software. This operation is accomplished by keeping all the text changes in a stack. Other example includes recursion, expression evaluation and conversion, parsing, browser, tree traversals, and etc. Operations on stacks can be described as push and pop. Push means adding an element on top of stack. Every time a push is performed, top value will be incremented, while pop refers to removing an element on top of stack. Every time a pop operation is performed, top value will be decremented. As we know that push means adding an elements onto stacks. Here you can see that in stack there are two values in stack on the left side, 23 and 93. Here top value will be 2. Now if we want to push value 10 in a stack, 10 will be added at the top position, while the top value will be increased to 3. Pop refers to removing an element from the stack. Here you can see in stack there are 3 values in stack, 23, 93 and 12. If we perform the pop operation on stack, top value is now 3. Now after the pop operation, the top value will be decreased to 2, while the 2 will be removed from the top position. Some scenarios how the stack perform. In case 1, when the stack is empty, the stack is called empty if it does not contain any element inside it. At this stage, the value of a variable top is -1. -1 is taken because in array implementation, the starting index of array is 0. So we take the initial value of stack to -1. In case 2, when the stack is not empty, value of top will get increased by 1 every time when we add any element to a stack. In the following stack, value 9 will be at 0 index, value 7 will be at 1 index, and value 10 will be at the index number 2. whereas the maximum value of stack will be 5 in the mentioned stack. In case 3, deleting an element from a stack is done by decrementing the top value. Value of top will get decreased by 1 whenever an element is deleted from the stack. In the following stack, after deleting 10 from the stack, top value will be decremented to 1. Top values define the stack position. Here are some top values and its meaning. -1 refers to the emptiness of stack, whereas 0 refers to only one element in the stack. N-1 is equal to whenever the stack is full, and n simplifies that stack is overflown. In array implementation of stack, the stack is formed by using the array. All the operations regarding the stacks are performed using array. Let's see how each operation can be implemented on stack using array data structures. Adding an element onto a stack is known as push operation. Adding an element into the top of stack is referred to as push operation. Push operations involve the following two steps. Increment the top variable so that it can now refer to the next memory location. Add element at a position of a incremented top. This is referred to as adding new element at the stack top. Stack is overflown when we try to insert an element into a completely filled stack. Therefore, our main function must always avoid stack overflow condition. These are the steps involved in push algorithm. In step 2, if top will be equal to n, it means that stack is full, alarming the overflow condition. If step 2 is false, then in third step, top value will be incremented. Let's suppose that we have a stack of maximum 5 value and current value of stack top is 2, as can be seen in the diagram. So if we want to add another value, top value will be incremented to 3. In step 4, value will be added at stack of top is equal to item. This means that item will be added at top is equal to 3. For example, value D is added at the location number 3 in the diagram. The algorithm for the push can be implemented as a push function in C++. Here, by using the if condition, we check the overflow condition. In else phase, similarly, top is incremented and value is added at the top position through a parameter via push function. Deletion of an element from the top of stack is called pop operation. The value of the variable top will be decremented by 1 whenever an item is deleted from the stack. The topmost element of the stack is stored in another variable, and then top is decremented by 1. The operation returns the deleted value that was stored in another variable as the result. The underflow condition occurs when we try to delete an element from an already empty stack. Here in step 1, pop algorithm is started. In step 2, we check the underflow condition by checking top is equal to 0. If it returns true, there is no value in a stack and we cannot go further. If it returns false, we take a temporary variable name item and store the top value, that is C, in item. Once the storage is done, step 4 will be executed and top value will be decremented to 1 from 2. The algorithm for pop can be implemented as a pop function in C++. Here, by using the if condition, first of all we check the underflow condition. In else phase, similarly, top will be decremented.